Today we are meeting with another topic of functions, that is composition of functions. Composition of functions means combining two functions together. This is the function gx and this is the domain of function gx and this is the range of function gx. Now this gx will be launched back again like this, and this function is fx, right? And then the result of this function is given a special name fgx, f of gx. The domain of this f function is the range of gx. This is called fgx function. In the fgx, what happens is f and g are two separate functions, right? We apply gx in the function fx. Let's take some examples and see. Example number 1, gx is equal to x to the power 3, fx is equal to 2x plus 3, right? We will find fgx and gfx here. In the case of gx, we apply g in the function f, right? So f is 2x plus 3, this x is considered as g, so 2x cube plus 3. This is the function f gx. In the function f we apply g. In this second case, gfx, in the function g we apply f. This is the function g. We have, instead of x we apply whole of f. gfx is equal to 2x plus 3 to the power 3, right? We will take another example. fx equals x plus 1, gx equals x minus 1. Here domain restriction is there. Now you know what is it, right? X is not equal to 1, and then again we are looking for fgx and gfx, right? Then fgx is, in the function f you apply g, right? In the function f you apply g. Instead of x you apply g is equal to 1 over x minus 1, right? So in the function you apply, in the function f you apply 1 over x minus 1, then this plus 1 is here. Okay, we'll take the other one, g fx. In the function g you apply f, right? In the function g you apply f is what? X plus 1, right? That means 1 over, instead of x you write x plus 1, right? And this minus 1 is there, right? X plus 1 minus 1, that is 1 over x. Therefore gfx is 1 over x. Is it clear? Gfx is 1 over x. We will take another example, example number 3, that is our functions are hx equal 3 minus 4x and gx equals x squared plus 2, and we will consider hgx and ghx and hhx and ggx. So there are 4 possible combinations we are looking for here. Let's take first one, hgx. hgx is equal to, in the function h you apply g, and then in the function instead of g, what is g actually? X squared plus 2. In the function h, wherever you find x, x is replaced by x squared plus 2. So this is hgx. Now you can mathematically simplify this. You can remove this bracket by multiplying by 4, and then you get minus 4x squared minus 5, right? Now you can pause the video and try all by yourself these other three questions, hgx, ghx and hxx and ggx, right? We will see whether you can do those things. Now we will come back to the video and check your answers. hhx, ghx is equal to gx, inside g you apply h, right? H is actually 3 minus 4x, so in the function g we apply, instead of x you apply 3 minus 4x, right? 3 minus 4x whole thing squared plus 2. So this is ghx, right? I hope you got this correct. We can simplify this algebraically a little, and then we will move on to the next part. What is that? hhx. In hhx, what we do is, inside h we apply h again, h itself. So inside h you apply 3 minus 4x, so 3 minus 4, inside this, instead of x you write 3 minus 4x. Now you can just open these brackets and simplify it like this, and then the final answer is 16x minus 9. Is it clean and clear? Right. We will move on to the next example, ggx. In this case what happens, inside the function g you apply g, right? Inside the function g you apply g. Gx is actually x squared plus 2. So inside the function g, this is g, this x will be replaced by x squared plus 2, right? You can simplify this like this, and then just square in this, and then you can write it, the final answer as x to the power 4, 4x squared plus 6. Let's move on to another, for example number 4. We have fx is equal to root of x minus 2, and here there is a domain restriction, not it, x should be greater than or equal to 2, and then gx is x to the power 1/3 plus 1, right? So there is no restriction in the domain. Then we have to find fgx, gfx, ffx, ggx. I hope here also it's better if you pause the video and then try it all by yourself, right? Then you know you have learned the thing, right? While I am telling, it is very easy for you to understand, but when you start doing it on your own only, you will find all kinds of problems. You face those problems and come back to the video and listen, then you will learn a lot. Then fgx, inside the function f you apply g, right, and then f, instead of g you write x to the power 1/3 plus 1. Then inside the function f, x is replaced by x cube, x to the power 1/3 plus 1, and then minus 2. So this can be simplified as x to the power 1/3 minus 1. Okay, so x is always greater than 2, therefore this is okay, right. And then next part, g f x, inside the function g you apply f, right. Then g f is what? F is root of x minus 2, and then in the function g, right, x is replaced by root of x minus 2. This is the final answer. And then again we have another, what is that? fx, in the function f you apply f, right. So f is root of x minus 2, and then in this root of x minus 2 minus 2, right. This is fx, right. And then ggx, ggx is inside the function g you apply g, right. Gx is what? Gx is equal to x cube, x to the power 1/3 plus 1, x to the power 1/3 plus 1. So x to the power 1/3 plus 1 to the power 1/3 plus 1, right. We'll go to the next example, 5. fx is equal to 1 over x and gx is equal to root of x minus 1 with the domain restriction. There are domain restrictions in both the functions. Here x is not equal to 0, here x is greater than 1, right. What are the questions we will see? Find what? fgx, gfx, ffx, gfx. Okay, here also I think now you will be able to do it all by yourself. Let's see. First you do it, pause the video and you do it, and then look for the answers. First one, fgx. fgx is inside the function f you apply g. fg means what? 1 over x. Sorry, g means root of x minus 1, and then in the f you apply g, 1 over root x minus 1. Next one, fgx, right, sorry, gfx, inside the function g you apply fx, right. Now what we do is g, f is what? 1 over x, so square root 1 over x minus 1. What is the next part? ffx, in the function f you apply f, right. Then in the function f you replace f by 1 over x, so it is 1 over x. X is replaced by 1 over x, then it is equal to x, right. So ffx is equal to x. Then we'll move on to the next one. What is the next part? Gfx is this, and then we are looking for gfx, ggfx of the same thing, ggfx. So what we do is, first we take gfx as this, and then in g you apply gf, right? Gf is this. So in the function g you apply this one, right? hx is x cube plus x plus 1. Px is x minus 1. Find what and what? hpx, phx, and hp2, and we will see hpx is what? hpx is inside the function h you apply p, right? So h p is x minus 1. So wherever you find x in h you apply x minus 1, then that will give you what? X cube plus x plus 1, that means x minus 1 cube, x minus 1 plus 1, right? This you can simplify as, this will plus 1 and minus 1 go off, then it is x cube minus 1 to x minus 1 to the power 3 plus x, right? Then this part we can do hp2. Now this x is replaced by 2, that is equal to 3. Here x is replaced by 2, that is equal to 3. Then phx. In the function p you apply hx, right? So this one is replaced by this one. So final answer is this plus 1 goes off with the minus 1, x cube plus x is the final answer. We'll take another example. hx is equal to 3x minus 2, gx is equal to 4x squared minus 1. What are we looking for? hgx, right? This one. Now you can see in the function g you apply h. H is actually 3x minus 2. So you go to the function g and replace this one, right? Next what? We are supposed to solve this equation GHX equals 3, right? GHX is equal to 3, that is GHX is this and equals to 3. So take this one to the other side, right? Now divide by 4, then you get 3x minus 2 whole thing squared is equal to 1. Now you take the square root on either side, then you get 3x minus 2 equals plus or minus 1. 3x minus 2 equals 1, or 3x minus 2 is equal to minus 1. X is equal to 1, no, x is equal to 1/3. This is our example number 8. Fx equals root of x plus 1. X is greater than or equal to minus 1. gx is equal to x squared plus 2. You got to evaluate gf minus 1 fg1 and solve this equation fg equals 2 root 3. First we will find gfx. When you find gfx, you get in the function g you apply f, right? F is equal to root of x plus 1, sorry, and then root of x plus 1 squared plus 2. This is equal to x plus 3, right? I think it is very clean and clear. Now in this gfx, x is replaced by minus 1. That is what we need, right? So what we will do is we replace this x by minus 1 and then you get 2. The other one, fgx. Fg means what? In the function f you apply g and then f x squared plus 2 and then g is x squared plus 2 plus 1, then x squared plus 3, right? X squared plus 3. Now we are supposed to evaluate fg1, so this 1 is replaced by 3, then fg 1 is equal to 2. Now we have another part of that question. What is that? Fg is equal to root 3. Here also I propose you to pause the video a little and then try it all by yourself. Then x squared plus 3 is this fg. They have said this is equal to 2 root 3. Now we got just a simple matter of solving this equation. So what you should do first is to square both sides. Then you get x squared plus 3 whole thing squared, root whole thing squared is equal to 2 root 3 whole thing squared. Then the square root here goes off. This will become 4 into 3. So this is x squared is equal to 9. X is equal to plus or minus 3. But you can't take both these solutions because of this domain restriction. So x should be greater than 3, greater than minus 1. Therefore, this minus 3 cannot be taken. Minus 3 is less than minus 1. So we have only one solution here, that is x is equal to 3. X, since because of this domain restriction. Is it clean and clear for you? Right. We will move on to the next example. That is example number 9. In the example number 9, we have fx equals 1 plus root x. X is greater than or equal to 0. There is a domain restriction here, you should note it. If you write this function without this domain restriction, it is meaningless. Gx is x minus 1 squared. What are the questions asked? Show that fgx is equal to x. We will try it and see. Here also you better pause the video and try it all by yourself and try to get this answer. What is asked is fgx. In the function f you apply g, right? So in the function f you apply g is x minus 1 squared. So 1 plus square root of g minus 1 squared. So this is equal to 1 plus x minus 1 is equal to x. So we have proven, right? Okay, let's move on to the next 10th, right? This is the last example. Hx 1 over x squared minus 1. Gx equals x plus 1. Here you got to know the domain restriction. X is not equal to plus 1 or not equal to minus 1. Find hg2 and solve ghx equals 5. Let's see. hg inside the function h, you apply g, right? G is x plus 1. So inside the function h, you apply x plus 1. So this x is replaced by x plus 1, right? Like this. And then you can open this bracket. Then plus 1 and minus 1 goes off. 1 over x squared plus 2x, right? Then you want g2. So this x squared, x is replaced by 2. This will be 2, this will be 4. 2 squared plus 4 is 8. So 1 over 8. Right? Ghx is inside the function g, you apply h, right? That is this, right? I think you can understand it. So they say that is equal to 5, right? This is equal to 5. Then you can take this to this side. So I think you can understand this algebraic simplification. This comes this side, then plus 1, then this. Okay, right. There's another example. P x equals x squared minus x plus 2. Qx is equal to root of x minus 1 with this domain restriction. Show that P Qx is equal to 0 has no real solution. So to answer this, first of all we got to find PQX. PQX is inside the function P, you apply Q, right? So that is P root of x minus 1. So that is root of x minus 1 squared, root of x minus 1 plus 2, right? We will simplify this. When you square this is equal to this, and you can take this as x plus 1 minus root x minus 1. Now we have to consider this is equal to P Qx equals to 0, right? So that means this is equal to 0, right? So to simplify this one, what we do is we take this root of x minus 1 to the other side and square both sides. Then you get x squared plus 2x plus 1 on the left hand side. This one will be x minus 1. So we take all these terms to this side, x squared plus x plus 2 equals 0. Here delta is less than 0. The discriminant b squared minus 4ac is less than 0. Therefore we can say this has no real roots. This is an exercise. You can try it all by yourself. I'm sorry I could not give you the solutions, but these are pretty simple things, so you can do it all by yourself with satisfaction and confidence. Thank you for watching the video, and please like this video and encourage me to give you more and more such beautiful videos and make your mathematics simple and interesting. And subscribe my channel also. Thank you so much.